Hi, my friends. It's Wednesday, April 20th. This is our math resource, and we are going to refresh ourselves on what we were working on before we went to break, which is expressions and equations. Today, we're going to work on two-step equations. We were doing one-step equations before the break. Now we're going to take it up a little bit, one notch or two, and work on two-step equations. All right, here we are sharing the brain pop video. You guys let me know if you can see it and hear it. Okay, Adolfo. You know what? Doing nothing sometimes is doing everything because your body and your mind needs a rest, and sometimes that feels good. So that's okay that you did nothing. You listen to your body. All right, here we go with Silly Moby. Let's see what he's gonna get into today. I see another chat. Hold on before I press play. Your screen is blurry. Thank you. That's what I was waiting for. I always try to do it this way. But that's okay. I will switch it out. Thank you. So let's see. I want to share screen one now. And that should clear it up. All right. Hello, Jaquan. Hi, Jaquan. I'm so happy that you're joining us. Hope you're feeling awesome. Hope your break was awesome. We're going to start now. We were learning one-step equations before we went to the break, and we're picking it up a little bit, and we're gonna review two-step equations, okay? So we have Silly Moby, who's gonna help us understand the difference between one-step and two-step.
I like this one. Now this is good wallpaper. How'd this get in here? Dear Tim and Moby, what are two-step equations used for? From Marcy. I think we're going to need a two-step equation to solve this wallpaper problem. Equations like this are one step. There's only one thing we need to find the variable, or the letter standing in for the number we don't know. We divide each side by 2, and with one step, we have our answer. Two-step equations involve more than one operation. As you might guess, they take 2 steps to solve. What did you find in the newspaper, Moby? Goober's Fancy Home Decor. Get 12 square meters of best quality wallpaper for $189, including the regular $33 installation charge. Best deal around, guaranteed. Lynn's Galaxy of Paint. Blowout special. All wallpaper is $11 per square meter. Call today. Right, we're going to put up the wallpaper ourselves, so forget the installation charge. We need to figure out which place has the cheaper per meter rate. Okay, Goober's is offering 12 square meters plus the $33 installation charge for $189. Let's call that unknown price per yard P. 33 plus 12 times the unknown wallpaper price, P, should get us to $189. We need to solve this for P. Yeah, this equation involves subtraction and division, so it has 2 steps. That 33 is just hanging out there on the left, so we can start by subtracting that from both sides. This gets us closer to isolating that variable, P. So 12P equals 156. Now, to fully isolate the P, we can divide each side by 12. which makes P equal 13. That's $13 per square meter. What do you know? Lynn's Galaxy of Paint is cheaper. Did you find a good pattern? Oh, no way. Nuh-uh, not happening.
He waited till he went to sleep. He got what he wanted as usual, that silly Moby. Okay, guys, so I wanted to give you a different reference video because we were watching vocabulary for the last 2 weeks. And sometimes hearing it from different perspectives helps a little bit because you see it in a different way. Don't know what's going on with my brain pop. It kind of disappeared. Okay, there it is. So let's practice with the, let's go over the vocabulary, the way the brain pop explains it. To get our brain, out of spring break mode. It's been almost 2 weeks since we talked about equations, right? So equation, remember, oh, this doesn't do it like vocabulary. Okay. Equation, remember equation, you need a equal sign. If you see terms like 3x plus 2 and there's no equal sign, that is an expression. An equation has to have an equal sign. So it should be 3x plus 3 equals 12. Okay. A variable in math is a letter or a symbol that's a placeholder for an unknown number. So 3, the x is the variable. Operation is, remember PEMDAS, it's adding, subtracting, multiplication, or division. Those are the operations when you're talking about math. The installation and the rate is going towards explaining how we use the 2 steps. I'm not going to try and define that because I don't want to make you confused, but they used it in an example of installing the wallpaper, how much wallpaper they needed and how fast or how cheap each piece. So that's the installation and the rate. It helps you understand why you have to use algebra in real life. And isolate. That is the first and most important step in solving equation in algebra. You have to get the variable, which is that letter, all by itself. Think of the pandemic when we were all isolated from going out from each other. We were all by ourselves. Okay, so isolation, get the variable all by itself. The next big thing in solving an equation, after you're isolating the variable, remember an equal sign makes things stay balanced. So whatever you do to one side of the equal sign, you have to do it to the other so that it doesn't become like a seesaw, okay? It has to stay equal, it has to stay balanced, okay? So let me pull up. My computer acts so weird. When you say it's blurry, then I have to reset everything. So give me 1 second. Yes, that's the one I wanted. Okay. So 5x plus 2 equals 27. This is an equation. And because it has an equal sign, you are able to solve it. A coefficient is the number that's kind of married to the variable. It's it cohabitates, so it's a couple, it's together with the variable. The 5 is the coefficient. The X is the variable. A variable is a placeholder for an unknown number, and it's a symbol, usually a letter of the alphabet. Trust me, I understand how this could be overwhelming. When we got to this part in math, when I was in school, I started hating math because when they start throwing the letters in it, it was too much for me to understand. I'm good at solving 1 and 2 step now, but I understand how you feel. Because there's a lot of vocabulary, it's a lot of steps, and it's a lot of different things to remember. 2 and 27 in math terms are called constants because they are numbers that do not have a variable attached to it. And the 5x, the 2, and the 27 are all considered terms. They're all different terms of the equation. So in this equation, there's 3 terms. The first step in solving this, as you can see, this is uploaded in your Canvas on the math resource page. So you can download this as a study guide to use when you're testing or practicing with Alex for your math class or wherever you need to use it. The first thing is first, isolate, get the variable by itself. And to do that, you have to use the inverse operation. Inverse is a fancy mathematical way of saying opposite. So because it's a +2, to do the opposite cancels it out, which brings it to 0, which helps you isolate the variable. So plus, if you have $2 and then you go to Dollar Tree and you spend $2, you have $0. The opposite of each operation cancels it out. So if it was multiplication, the opposite is division. If it's subtraction, the opposite is addition. And the opposite is multiplication. Okay, those are the 2 pairs that are married. Adding, subtracting, subtracting, adding, multiplication, division, division, multiplication. Okay, so because I subtracted 2 on the left side of the equal sign, right here, I have to do the same thing to make that equal sign stay balanced. Otherwise, it's going to be like lopsided because I only did one thing on one side. I subtracted 2 on this side of the equal sign. I'm going to subtract 2 on this side of the equal sign. 27 minus 2 is 25. I'm going to bring down my 5x. I haven't touched him yet. I'm still trying to isolate the variable, which is that x. Okay. To get the x by itself, anytime a coefficient is hanging out next to a variable, whether it's a b or an a or a y or m, doesn't matter. Anytime a number is standing next to as a coefficient to a variable, that means it's going to be multiplied. The opposite of multiplication is division. To get that x all by itself, I'm going to divide 5x by 5, okay? But if I did that to the left, I have to do the same thing to the right. If I divide it by 5 on the left side of the equal sign, I have to divide by 5 on the right side of the equal sign. 25 divided by 5 equals 5. So x equals 5. And I still forgot to get my little plug-in so I could show you the plug-in for my, my wall thing. There was a commercial that would say, plug it in, plug it in. I want you to plug in your variable. That's the last thing to make sure you are correct. Where the x is, the placeholder, the unknown, we're saying it is a 5. Plug in the 5 into the same equation and see if it balances out on both sides of the equal sign. So instead of saying 5x, we're saying 5 times 5 now, plus 2 equals 27. PEMDAS, there's a parentheses, do the parentheses first. Multiplication, do the multiplication first. 5 times 5 is 25. No division. Next is addition. 25 plus 2 equals 27. 27 on this side of the equal sign and 27 on this side of the equal sign is balanced. And that shows you that you got it right. Okay. So this is how you solve one variable, but in 2 steps. Okay. Now, in all honesty, this is going to keep going. They're going to add way more terms. They're going to add more variables. It's not going to always be adding and subtracting. Sometimes it's going to be a fraction or a decimal, but the steps stay the same. Okay. I'm going to let you go into Quizizz and practice. And it's still kind of simple until you get the steps repetitive and it's automatic to you. And then we'll start with fractions and decimals and the multiplication, division, and exponents and all of that thrown in together. But I want you to start out with the basics, get the rules down, get the steps down, and we'll gradually move you up, okay? Any questions about that? Is that helpful? Does it make sense? Does it make you more confused? I have one more video because Miss Wright, if you have her, she uses him a lot. So, but I already knew this before Miss Wright. This guy, Mr. Rob from Math Antics, he has an awesome way of showing in real life what we are doing with these crazy things we have to learn in algebra. So I'm going to show you his video, and then I'm going to let you go practice, okay? My job. Because I thought it's part 1 and part 2. Okay, just want to make sure. He has 3 million views. That's how good he is. And today, he does a really, really good job.
Versus physical changes.
So hopefully, if I
in this video, we're going to learn how to
he's able to help you like really understand it because he's really, really good. And I have this link of his playlist on that sheet on the canvas, but I'll also throw it in the chat too.
solve equations that have just 2 math operations in them, 1 addition or subtraction and 1 multiplication or division. And the concepts you learn in this video will help you solve even more complicated equations in the future. Now, as you might expect, equations that have 2 arithmetic operations in them are going to require 2 different steps to solve them. In other words, to get the unknown all by itself, you'll need to undo 2 operations. But that doesn't sound too hard, right? I mean, we learned how to undo any arithmetic operation in the last 2 videos. And that's true, but there's a couple reasons that make 2-step equations a little trickier to solve. The first is that there's a lot more possible combinations of those 2 operations. And the second is that when there's more than 1 operation, you have to decide what order to undo those operations in. Hello? If you need to know what order to do operations in, just follow the order of operations rules. You did watch that video, didn't you? I sure did. But the order of operations rules tells us what order to do operations, not what order to undo them. Oh, well, then could we reverse the order since we're undoing the operations? Now that's a good idea. Well, of course it is. When solving multi-step equations, that's basically what we're going to do. Using the order of operations rules in reverse can help us know what order to undo operations in. But it can be a little tricky actually putting it into practice. So, to see how it works, let's start by solving a very simple two-step equation. 2x plus 2 equals 8. In this equation, the unknown value, x, is involved in two different operations, addition and multiplication, which is implied between the first two and the x. And to undo those two operations, we need to use their inverse operations, subtraction and division. But the question is, which one should we do first? Like many things in life, the order we decide to do things in can make a big difference. Oh, come on. There's got to be an easier way. First socks, then shoes.
Socks, then shoes. Socks, then shoes.
Fortunately, in math, we have a special set of rules that tell us what order to do operations in. Those rules tell us to do operations inside parentheses or other groups first. And then we do exponents. And then we do multiplication and division. And last of all, we do addition and subtraction. Those are the rules you need to follow when simplifying mathematical expressions or equations. But solving an equation is different because we're trying to undo any operations that the unknown value is involved with so that the unknown value will be all by itself. So when solving equations, the best strategy is to apply those order of operations rules in reverse. Using the reverse order of operations is not the only way to solve a multi-step equation, but it's usually the easiest way. Just like it's much easier to take your shoes and socks off in the reverse order that you put them on. Are you sure it's socks before shoes? Since the order of operations rules tell us to do multiplication before we do addition, we should undo addition before we undo multiplication. So first, we undo the addition by subtracting 2 from both sides of the equation. On the first side, the plus 2 and the minus 2 cancel each other out, leaving just 2x on that side. And on the other side, we have 8 minus 2, which is 6. Next, we can undo the multiplication by dividing both sides of the equation by 2. On the first side, the 2's cancel, leaving x all by itself. And on the other side, we have 6 divided by 2, which is just 3. There, we've solved the equation using the order of operations rules in reverse. And now we know that x equals 3. That wasn't so bad, was it? Let's try solving another simple two-step equation that has division and subtraction in it. X over 2.
I believe that we do not have that in the quizzes. So I'm going to save that for next week because I just want you to focus on adding and subtracting today. Okay. So I'm going to throw the link somewhere. Where is it at? Where is it at? I'm going to leave this. Oops. Sorry, guys. It really stinks that my monitor doesn't work for you guys because it makes me so confused toggling back and forth. Okay, wait a minute. Here it is. And give you the link for the quizzes. And then you'll be on your merry little way for the rest of the afternoon. See you guys tomorrow in ELA classes if you're not testing. Uh-oh. Sorry, guys. The switcheroo thing. Okay. All right. I promise you I had did this already. I don't know where it's at. Okay, here it is. Yes, I'm going to give you the link right now. I promise. Solving one. Yes, 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 yes. Everything gets jumbled when I share my main monitor screen. So I have to look for everything over again and toggle back and forth until I find the right stuff. So my computer, like the things, what do you call this? Not cancels, but it like logs itself out if I don't use it in like 10 minutes. It goes to sleep and then I lose everything that was open. And when I switch to the other monitor, because it's blurry, then the other monitor goes to sleep. So now I have to find everything again. All right, here you go. You should be having it coming in 5, 4, 3, 2, 1. All right. Now you can't see it because it's on my other monitor. But if that's the link for the quizzes, when you finish, you're free to go. If you can't log in from that link, use Join My Quiz, and the game code is 6219-6341. And thank you for coming. You guys are awesome. Let me give you guys the calculator. It's time for the calculator. It's time for the calculator. I think you guys are too young to even know what I'm talking about. It used to be a song, like a party line dance song. But you guys are too young. All right, here is the calculator. I'm gonna stop recording and stop sharing and all that kind of stuff. So I'm gonna mute my mic so that you can concentrate.